Okay, can see the
Yes,
note? Anyone?
I can see.
Can okay, good. Okay, guys, do you tried the design experiment for this D3? Do you manage to draw the appearance? How does it looks like? How are you going to use it? So this experiment is about efficiency of a motor. So some apparatus is given here. How to find efficiency of a motor and prove this equation. Efficiency is AWN. A is a constant. W is the load used to carry the used by the motor to lift, and H is the constant, right? So you need to calculate the not Hn. You need to find the A and N. So you need to prove this equation is valid or not. Yeah, how do you can prove? How do you find efficiency? Efficiency is what? Output over.
Wait, now. Power, power,
Yeah.
power output over power input.
Yeah, power output or power input.
Wait,
How?
is it?
What instrument do you use? Can calculate input power and output power? Input power, you need to calculate how much of input power you give to the motor.
The current.
The current and the voltage, right? You must have a current and voltage need to be measured. So you need to use a ammeter, voltmeter in the motor section. Then how do you going to calculate the output power?
Power used to lift the weight.
Yeah, power used to lift the weight. How do you can calculate the output power? You calculate mgh.
Yes.
And over time, time taken to lift a certain height. Okay, so the rough setup should be like this. This one setup. Okay, so this is one setup to find the efficiency of a motor. So you see, you must have a ammeter here. You must have a voltmeter cross to measure the voltmeter across the motor. Ammeter to find the current flow in the motor. So I times will give you the power input. And the motor, a string was connected, passed through the pulley and slotted mass. The slotted mass is allowed to move up. And we measure the time taken for the slotted mass to move up for a certain height. The height rises, we measure by using a ruler. And of course, the motor was G-clamped, okay, so that it never moved anywhere. So this is how the setup looks like. To addition, maybe the time interval for it to rise, you can use two what do you call light gate also can use to find a time interval for it to rise. Two light gates connected to the electronic timer instead of stopwatch. Okay. So I hope you have this type of idea in your mind when you think about this question. Must have current, ammeter, voltmeter to find the input power, and yeah, mgh over time to give your output power. Okay. So the next, the independent variable must be, which is the variable you're going to change. You change the load, the weight of the load. And dependent is the efficiency of the motor. A constant is the power given to the load. Power for a given load. Power given for the motor is a given load is constant. Make sure the I and V is constant. Okay. So procedure focus to how do you measure the load independent? How do you measure the dependent? How do you make the power constant? These three procedure. Set up the apparatus as shown in the diagram, voltmeter parallel to the ammeter in series with power supply. It's already shown in the method in the diagram. So you never write here also is fine, but better write lang. The output power measured by using mgh over T. 1 mark for the This could be extra detail because you're explaining how to calculate it. Where M is the calibrated mass, T is the time, and the rise up height. Input power is given by P equals to IV. Efficiency is output or input. Repeat the experiment varying the load while keeping the power given load constant. Okay, here please add another two things. The load is measured. The load is measured by a weighing balance. The height is measured by using a ruler. But here you never mentioned a ruler is accommodated here, so you get a mark for the measuring of height by using a ruler. But please add here, measure the load, measure the mass of the load by using a weighing balance or top end balance. So please add that in the procedure. Okay, I already post this in the Times. For time being, just try to understand the idea.
Okay.
It's already under practical D3. I already posted, so you can check this document over there. Try to absorb the idea. So after that, analysis. For the first time, log graph to be plotted. Why plotted? Because the equation is what? The equation is efficiency is equals to AWN. So you want to plot A and N. So the N you need to find. So you have to bring down the N. So you have to bring log or long. Okay. So how the derivation going to be for this? Derivation log or long? So that's maths, right? You should know, right? So of course, how are you going to be? So you can use log or log. Both accepted. Hold on. Let's go. Trouble. Okay. So yes. So AWN. So bring log or log. So log E. So log A. What is that? Plus N log W, right? Okay. So this you have to show the final derivation. You show. So plot log E versus log W, where the gradient is what? N and your intercept is log A. Log A. So what versus what to be plotted? You're showing this final, show the final one. You get 1 mark. You say log E versus log A, you get 1 mark. And M and C together, you get 1 mark. Should be an extra detail. You can, we have said it's a straight line, pass through origin, you get 1 mark. The M and C might be extra detail mark. Okay. So you can accumulate more than 3 actually in your analysis. Okay. Okay, so that's the idea. So graph log E versus log W to be plotted. The graph is a straight line, then the equation is valid. The greater the graph gives the value of N and sign for constant N. And put the y-intercept. The y-intercept will be what? The y-intercept will be, please add, the y-intercept will be log A. Okay, always tell the gradient and the y-intercept. Y-intercept should be log A. Okay, please add y-intercept is log A. Okay. So because now precaution, one safety. Of course, wear goggles when handling with the wires. Okay, if it snaps, then it might come towards you. Okay, hits you. So especially your vision, your eye. So it's safe by using goggles. Do not allow high currents, may overheat and damage the motor. And this is all safety. Right one. Extra detail, more details. This is some of it. So do preliminary experiment to each change load so that the current and the voltage suitable value for time, load, and current is used. Because excessive current voltage is going to rise very fast. So time is going to be very short to go up. So your reaction time can dominate the time. So maybe the value will become less accurate. So don't want it to rise very fast. Very slow is fine, but not very fast, not very too slow also. So do a preliminary experiment to get which current voltage to be used to do the experiment. Okay, stopwatch simultaneously as the circuit in which the already present voltage current pre-adjusted rheostat. Start the stopwatch when the load when you switch on the motor. G clamp to hold the securely on the table. Pulley must be oiled. Whenever there is a pulley, you say frictionless pulley to be used. And keep the emitter reading. Rheostat need to be adjusted. Yeah, how to make the power constant? By making the I and V constant. How do you make the I constant? By adjusting with the rheostat. Use a rheostat. Use a rheostat. Adjust the rheostat accordingly so that the current here always the same. Because if you prolong connecting it, the heating going to cause the current to drop. So you need to adjust the rheostat so that the current is constant and the voltage is constant to get the same power. Okay, so this is one setup. Any questions?
We can't just like let it cool down every time we do the experiment. Every time we do a different load, we let it cool down first.
It's not wrong, but I never come across as a answer in any mark scheme. Normally they maintain it by adjusting the rheostat.
Because like if we change the rheostat, but it's still hot, I mean, yeah.
It's still hot, but oh yeah, okay.
Yeah.
But make sure the I and V is always the same. Yeah, correct. But I never come across any mark scheme stating that. Normally rheostat. You as a supporting factor, you can write that. Okay. Okay, so yeah. So you go and check in the times. Under practical, I already post this for your reference. Okay. So for next week, try to finish this report. Try to get some guidance to do this. Next week, please do D4, the next experiment. For next week discussion, I want you to try with D4. Okay, think about D4. Try to come out with the diagram and everything. We will discuss next week. Okay. Okay, the next experiment I asked you to do is C3, right? C3, yeah. C3 or C5, huh? Which one I asked you to do?
C3.
C5. Yeah.
C3.
C3.
C4.
Okay.
C4. Sorry.
C4. Okay. So guys, do you tried the C4 already? Haven't tried yet. Okay. I only can discuss if you try the question. Okay.
I tried already, teacher.
Tried, C4. C4 is which year is this? Oh, sorry. C4. Let me check the 207. Okay. Okay, so hope your graph is with you. So this is your paper 4. Paper 5, right? Okay, so let's recheck the mark scheme. Okay. So we go concurrently. First approach to data analysis. The first mark is you rearranging it to this format. R equals rho L squared over V plus R naught. Correct comment. The question is asking for what? Sorry, C4, right? Okay, so first question is explain why plotting graph R against L squared would enable us to confirm the relationship. Okay, so what do you have to do? You have to rearrange this so that it like it. Oh, where's the answer? So R equals rho. So you said by plotting R versus L squared, by obtaining a straight line where the gradient is what? Rho over V and y-intercept as R naught would enable us to confirm the relationship. Okay, so that should be your first answer. Your first answer. Okay. Okay, next calculate and record the value of L squared in centimeter squared in table, include the table absolute error for L squared. So here only 2 column given. You 2 column you fill with what? 1 column you fill with L squared. They want absolute error for L squared. Yeah. So 1 column is L squared, another column is changes of L. So L squared and yeah. Okay, so you have 2 columns. So of course, first one is what? L squared slash centimeter squared. Another one is changes of L, okay, slash centimeter squared. So put your values. Okay, how do you calculate your values? The 2 method I told you. Okay, the easiest method is find the L max minus the L actual, right? Actual, you get the changes of L for the changes of L. So for the first case, L max is 6.4 squared, right? 6.4 squared minus L actual is 6 squared. So you get the changes of L. Okay. So we go to the census, go to the coordinates. The value of L squared is expected for this. Okay. But let's go for the changes of L. Changes of L should be, this is your changes of L. Check your data. Is it your changes of L? They give a range. Why they give a range is because it's got two techniques to find the error. One is by using the formula, another one is the maximum minus the actual. So must fall in between this range. 4.6 to 5, 7.8 to 8.2, and so on. Okay. So I hope all of you get this data. Okay, error file square. Anyone got a different value? Okay.
No, teacher, the value I got is all of the value times 2.
You got times 2.
Yeah, I got 2 times the error, like 4.6, I got like 9.2 like that.
Yes. It's error of L squared, right?
Yes, I use the maximum minus the actual method.
Yeah, maximum minus the actual. So maximum minus actual, maximum is what? Maximum is 6.4, right? 6.4 square lah. Yeah, 6.4 squared minus 6 squared. You get changes of L squared, right? Changes of L squared. How much you get? 6.4 squared minus 6 squared.
Oh, sorry, teacher. I minus the wrong value. Sorry, I minus off the minimum one.
Oh, okay. Oh, maximum, minimum, you get double.
Oh yeah,
Must
sorry,
be
teacher.
maximum with the actual, eh? Okay, so yeah, so we got these coordinates. If this you screwed up, your graph going to be problem, and it's going to be a chain reaction. Eh? So be careful. Okay, so next. So we just get the idea. Calculate and record the value of 8. So plot the graph as usual. We plot the best fit and worst fit line. Okay, determine the gradient and best fit and errors. This is the normal method. Eh? So the marks Kim said the graph points are plotted correctly. All 6 required mark must be less than half a small square when you plot. Mark. Line of best fit is correct direction. So you get 1 mark. Worst acceptable line. Pass through all the error bars. Within error bars, you get 1 mark. So 3 marks. You see, this is old past year. New past year. Line of best fit, they tell you which coordinate need to be passed through. They give a range of coordinates. If you pass through that coordinate, then you get a mark. Yeah. This is old past year, they never tell the coordinate. Okay, gradient of best fit line. Gradient of best fit line, you should get in this range, 0.55 to 0.56. Out of this range, you lose mark for the gradient. (0.55 to 0.560). After your graph, all write 3 significant figure. I told you that. So value of rho calculation. So the gradient equals to rho V. That's a part D question, right? Part D volume. The volume is given this. Determine the density, include the error bar in your unit. So from the formula, you know already. What is your gradient? Oops, no gradient. Oops. Okay. So the gradient just now we derived the formula, right? The gradient, I think we got rho V, rho L. So the gradient is rho V, rho V. So you know the gradient, you can find the density, volume just now given one. So density you get in the range of 10.3 to 10.6. Do they want uncertainty with the answer? Get the value, include the errors. So you need to calculate the errors. How do you calculate the errors? For density, what method do you use? Density equals to what? Sorry, always keep problem. Why? Sorry, guys. Okay, I think something's. Okay.
Teacher,
So
I think we have to off the active pen, right?
It off what?
Off the active pen.
The active pen. Oh yeah, sorry. Thanks. Okay. So now how do you do the D? Part D expected is rho equals to what? The gradient is rho V. So you want to find density. You want to find density. So density is M over V. So you write the formula, changes of rho, changes of M over M, changes of V over V to find your changes of rho. Okay. So this is one way of finding the changes of rho. Okay. So we see the mark scheme. Mark scheme, unit of rho. So rho volume. Oh no, this is not density. This is rho. Resistivity. Resistivity got this range. So the resistivity is ohm centimeter. Okay, remember guys, in your exam, if they give in your table and they give centimeter, you leave it as centimeter. You don't need to convert. No need to convert. I never seen, very rare they do conversion here. So next error for L square, just now we saw within the tolerance. Check error in gradient. The method is checked. Gradient of best field line minus gradient of worst field line is shown clearly. Get one mark. Method to find the rho, the worst field gradient times the volume minus the density, actual density. You get the rho in this range, 0.4 to 0.6. Okay, any part you don't understand here? So this is what accepted last. So final answer, the gradient must be 0.55 to 0.56. Okay, your density must be 10.3 to 10.6. Take down, your rho must be, your uncertainty for rho is 0.4 to 0.6. Okay, any part you don't understand?
Teacher, if my error bar, just now the error I calculated is double the value, right? Then I plotted my error bar and then I plotted my line of worst fit, and then I get my gradient. And then if I use the gradient to calculate the next step, will I get error carry forward, or will I lose all the mark?
In the real examination, you might lose the mark, but not all. I can say if your data wrong, it should be error carry forward, right? ECF, okay, ECF. But you can expect it, like out of 15, you're going to lose like around 4 to 5 marks. Okay, not all going to be ECF. For ECF, check first and last point for ECF. So here they give ECF. Most be with tolerance. For ECF, check first and the last points. First and the last points. Error of gradient. Oh no, you see, Let's see your data here wrong. On top is wrong. For the gradient, the error you get marked because they're just checking the method. Okay. For D, for 1 mark you get for the method, you get mark, but the value you might lose mark. Okay. So some you'll get, some you won't get. For method questions, all you get mark. Okay, so that's why be careful. Don't make mistake in your data. Very important. Okay. Any other questions?
Teacher, for the error in the resistivity, right? I used the gradient from my best fit and then I calculated for the resistivity, and then I used my gradient for my worst fit and then I calculate the resistivity, and then I minus off the two, then I consider that as my error. Is it correct?
Oh, that's another method to be used. But tell you the truth, like reason mark scheme, right? The reason mark scheme, they started to use this more. This formula method more. Last time they used to give both. This formula is allowed. Another one they said the best width gradient, best density minus the best row minus the worst row. Sorry, best row minus the actual row. They give both method. The reason mark scheme, the other method looks like face out. They never really show. The one they show in the mark scheme is the formula. So my advice is both is correct. It's not wrong. But because the mark scheme looks more going to this formula, I think better go for formula for the last part.
But
Okay.
inside the question, right, it didn't state the value of the error for the volume. So should I just assume it or?
No. Did they give
Yeah.
don't have error?
They give the volume, but they didn't give the error.
Oh yeah. Sorry. Then the equation, because no volume, so you don't have value. Just this one. So changes of rho equals to changes of MOM. So use the formula. Okay. If the V don't have errors, no need to include it, right?
Also, I just exclude the volume.
Yeah, as what you learned in AS last time. If the volume, if that value don't have error, it won't involve in the uncertainty formula, right?
Oh, yes.
Then only include. But of course, to calculate rho, you have to use that formula lah. There the volume involved, right? But for uncertainty for rho, the volume, because it don't have uncertainty, the volume won't involve. Okay, guys, any other questions? This is a Juno 7 paper. So let me post this in your times later. Okay, I haven't posted this yet. Okay, any other questions? Okay, so we continue for next week. Please try to do C5. Try to do C5 and go ahead do with your D4 and C5. D4 for design, C5 for your analysis. Just continue doing the paper. Okay. Any other questions? No questions. Okay. Another one thing. I added more papers here under A2 trial papers. Under A2 trial papers, I add the reason one at the bottom. The reason trial papers has been added. So more trial papers is available for you under A2 trial papers. So now we are almost about, I can say, another 4 topics left. Okay. But I think you can do about 80% of the paper 4 already. About 80%, 85% of the paper 4 you can do now. Okay. So another 6 weeks to go for your trial. So I want you to start now itself to do the paper 4. Paper 4 past trial papers or your past years. Anything you feel proper. Recent past years and the trial. Okay, started do the papers. Okay. So that's about practical. So now we have about another just about 15 minutes. Okay. Let me introduce the new topic. We go to the new topic. Okay. Okay, the next topic we're going to go about is nuclear physics. Okay, you can see the slide, right? Can okay. So after quantum physics, we're going to talk about nuclear physics. Nuclear physics also is modern physics. A lot has been contributed by Einstein again under nuclear physics. Okay, so nuclear physics, those who took SPM, I think you learned this before in your SPM, if I'm not mistaken. Do you learn about binding energy in your SPM? Anybody? You learn about binding energy? No, can't remember. Okay. So I think you learn about binding energy. You not really learn about radioactive decay. Half-life you learn, right? Half-life we learn in your SPM. Here we go in depth, more depth about it. Okay, so this is a continuation of AAS. Okay, first we're going to talk about E equals to mc squared. Okay, let's start the lesson for nuclear physics. So E equals to mc squared. So anything comes out physics or science, the formula will appear always is E equals to mc squared. Okay, very important formula, famous for Einstein. He wrote a lot of equations, but the one most famous and simple is this equation, E equals to mc squared. Okay, what is the meaning of this formula? When do you use this formula? This formula tells that mass and energy are interchangeable. He's the first or the only one scientist says that mass and energy are two different forms of the same substance. So energy can transfer to mass, and mass can transfer to energy. This idea. So if you want to know 1 gram of mass when destroyed to become energy, so how much of energy will be released? So just put this mass as 1 gram times the speed of light squared, you get that energy going to release. Okay, so the energy going to release is a lot, 1 gram change to energy. So E equals mc squared. Nobody, of course, whatever you say, going to be very, very futuristic. Okay, like a fairy tale story. Nobody can believe it. But of course, when they start to believe these equations, of course, after the bomb dropped in Hiroshima, the energy is so huge. Okay, mass has been destroyed. Okay, so when mass is destroyed, at which level mass is destroyed? Mass found to be destroyed, not our daily life. It was found to be destroyed in where? During nuclear process. Okay, it happens only at the nuclear level, at a microscopic level. Okay, at microscopic level, when nuclear reaction, when two nuclear merge, do fusion or fission, they found some mass is like lost. Okay, some mass lost and tend to become energy. In a macroscopic world, like a big reaction, they never see that mass is destroyed. Okay, yeah. So when that happened, during nuclear reaction, fusion or fission. Okay, so what is fusion? Anyone? What is fusion? The merging of
Two nuclei.
two, what type of nucleus? Two lighter nuclei, to the merging of two lighter nuclei to form a heavy nucleus and releases energy. Fusion. Where fusion happens?
The sun.
The sun. The only place where the fusion is happening is currently sun. Okay, do we have, is there any man-made fusion successfully done?
Hadron collider. Yeah.
Hadron collider, but they cannot sustain the fusion.
Yeah, it's only like 15 seconds and then it.
Yeah, couldn't sustain it. Difficult to have fusion. For a fusion to occur, the two nucleus must overcome the intermolecular force, electrostatic force, which is very huge. You need 1,000,000 degrees Celsius for fusion to happen. So next, of course, fission. Fission. What is fission? When a heavy nucleus split to two lighter nuclei and releases energy. Okay, this happens when a neutron was blast into the nucleus, into the heavy nucleus. All the nuclear reactor we have around the world is all our fission. Okay, but scientists, not to say scientists, yeah, everyone's, especially the science community, their dream in the future is to have a fusion reactor. Okay, fusion reactor. Anyone? Why fusion better than fission? Anybody?
More controlled.
More controlled. The energy release is quite big as fission. Okay. The better answer, anyone? Why fusion better than fission? Because of the product. Okay. Fusion product is like sun. Two hydrogen merge form what?
Helium.
Helium. Sun made of what type of gases? Hydrogen and helium, right? Hydrogen is the fuel. Helium is the byproduct. So two hydrogen merge form helium. So the product is helium. Helium is it dangerous? Helium is a inert gas.
Yes.
So the product is not that dangerous for fusion, and not much of radiation comes out from fusion. Fission comes out with a lot of radiations, so very dangerous fission. Okay. Another one is fusion seems to be giving more energy compared to fission. Okay, so that's why scientists want to go for fusion. Main reason is the product is less dangerous compared to fission. Okay. Okay, so now we go in theory about how mass is destroyed. So first, the mass called mass excess. You're going to learn about mass excess or mass defect. So when a proton and neutron merge to form a nucleus, okay, when the proton or neutron merge to form a nucleus, for example, I go for helium. I go for helium. Helium is 4-2, right? Helium is 4-2 made of how many proton, how many neutron? 2 proton plus 2 neutron. So the 2 proton and 2 neutron, when they merge, form helium. The science found that the mass of the helium is smaller than the mass of the 4 nucleons. They found the mass of the nucleus is slightly smaller than the mass of the individual nucleon. So some mass disappeared. Okay, so when a proton neutron come together to form a nucleus, the mass of the nucleus is less than some of the masses separated by the proton and neutron. These differences in mass called mass defect or mass excess. So what is mass excess? The total mass of the nucleon made the nucleus minus the mass of the nucleus will give you the mass defect. It's mass defect. Okay. Mass which is missing. Mass which is missing. Okay, because it tend to become energy. Okay. So the Z is the number of proton and N is the number of neutron. So what is mass excess or mass defect? The differences between total mass of the nucleons minus with the mass of the nucleus made of that nucleons. It's called mass defect. Greater the mass defect, okay, I tell you, greater the mass defect, greater the energy will be released. Okay, that's the idea. Okay, so you need to understand what is meant by atomic mass unit. Chemistry, you really learn this, right? Atomic mass unit. What is atomic mass unit? 1U. 1U. Atomic mass unit 1U is defined as being equal to the 1/12 of the mass of the carbon 12 atom. So recall back in exam they asked what is meant by atomic mass unit. One unit. The atomic mass 1U is equivalent to 1/12 of the mass of a carbon 12 atom. The 1U equivalent to 1.66 times 10 to the power negative 27 kilogram. Okay, so remember helium 4-2, the nucleon number is 4. What is the mass of helium? Mass of one atom of helium is 4U, right? 4U. U stands for 1.66 times 10 to the power negative 27. Okay, atomic mass unit. So mass of proton, if we write mass of proton, we know is 1 on top, the proton number, but if you write in 6 decimal places, there is some value at the back. So 1.007276 U is actual mass of proton. You don't need to remember this digit. Okay, in exam they'll give you mass of the neutron. The mass is slightly bigger than the mass of proton. When you go, you only can see that if you write 6 decimal places. Normally we say mass of proton, mass of neutron is like 1, 1. But when you go to 6 decimal places, neutron is slightly heavier than proton. Mass of electron is this much, very small. Okay. Any question from this slide? Okay. Go to the next slide. Okay, now, one example. Calculate the mass defect for carbon-14 nucleus. The mass of carbon-14 is found to be 14.003240 U. This is the mass of the nucleus of carbon. Calculate the mass defect. How do you find mass defect? Mass defect is the total mass of the nucleon minus the mass of the nucleus, right? How many nucleon it has? Got 6 proton and 14 minus 6, how much? 8 neutron. So the mass defect will be how much? This is how the working. Carbon 14 has 6 proton, 8 neutron. So mass defect is 6 times mass of proton plus 8 times mass of nucleon minus with the mass of the nucleus. So the mass defect is found to be this much in U. Okay, next, calculate also the energy equivalent of this mass. The mass defect which is lost equivalent to how much of energy? So we use the Einstein's formula, E equals to mc squared. So m must be the mass defect. The m here is actually the mass defect. Mass defect, the mass which is lost. So, but remember, when you use formula, mass must be in SI unit. Don't put in U. So you put it in 1.66 times 10 power negative 27. Okay, times with c squared. You get answer in terms of joule. But you see, according to this wiki, they put it in mega eV. Mega eV means you divide by elementary charge law. 1.6 times 10 power negative 19. You get in terms of eV. You've done this before, right? Joule change to eV. What do you do? You are by 1.6 times 10 power negative 19. That's what has been done here. 1.6 times 10 power 19 divide. You get answer in terms of EV. Okay. Mega means, I think the answer got 10 power 6, so they put in mega. Yes, any questions from this slide? Okay, this is called mass defect. Okay. Okay, so this is the introduction for today. I don't want to go further. Okay, so what do you introduce today? E equals to mc squared. What is the significance of this formula? What Einstein's idea? Mass, energy are interchangeable. Okay, so then where they happen in the nuclear stage, and introduced with mass defect. Mass defect means when the nucleon form a nucleus, some mass is disappeared. That's called mass defect. Okay, so we learn about atomic mass unit. Then we learn one example how to find the mass defect of carbon, and that mass defect equal to how much of energy. Okay, any questions? In next lesson we will be go for binding energy. We explore the binding energy. Yes, so good. So please do your practical for next week Monday we discuss. Okay. So tomorrow we will continue with this. Any questions? No question. Okay. See you then.